In this video, I'm going to go over how to use the law of cosines. Now, hopefully you feel pretty comfortable using the law of sines at this point. And the law of cosines, we use that when the law of sines is not actually able to be used in the first place. So remember, to use the law of sines, you must have at least one pair of angle and side length. And if you don't have that, then you're not going to be able to use the law of sines. So this is where we'll enter and use the law of cosines. There's really two ways we use it. If we're given at least one angle, then we should be able to use one of these three to find the missing side length. If we are given zero angles and only have three side lengths, then we'll be using one of these three. Okay, so let me show you an example where we're able to at least have one angle, and I'll show you why we can't use the law of sines right off the bat. All right, so here's triangle A, B, and C. And we have angle A is 30 degrees. Side length A, we don't know. Side length B is 12. And side length C is 24. Okay. Now, one thing I always think about when I do these problems, because when you do these on the test, I'm not going to be like, oh, here's where I want you to use the law of cosines first. Here's where you use the law of sines first. So I always try to use the law of sines. It's just a little simpler and easier to remember. But again, if I'm going to use the law of sines, I need to have at least a pair. So when I say that, I mean an angle and a side length. Okay, so I have angle A, right? I know angle A, but I don't know side length A. I know side length B, but I don't know angle B. I know side length C, but I don't know angle C. So since I don't actually have any pair where I know the angle on the same side, then I have to use the law of cosines. So I'm going to use the the law of cosines to find angle B. All right, so setting this up, it's going to be, I don't know why I said that. I'm going to use the law of cosines to find side length A. So it's going to be A squared equals B squared plus C squared minus A squared, okay? And then you're going to have, not that, my bad. B squared plus C squared minus 2BC times the cosine of angle A. There we go. That was it. Again, I'm using this version of the formula here where I add the two other sides, square those together and add them, and then subtract 2 times those two sides times the cosine of my angle that I do have. All right, so let's plug in what we know. So I have 12 squared plus 24 squared minus 2 times 12 times 24 times the cosine of 30 degrees. All right, now when I go to the calculator to find this, right, you'll notice that it says A squared, right? I don't actually want A to be squared, I want just A. So I'll be typing all this in, but the square root around it. So if you pull up your calculator, right, make sure to click the wrench first, make sure you click degrees. So I'm going to type in square root, right? And then I'm going to have, I believe it was 12 squared plus 24 squared minus, confirm I got that right, yes, 2, so minus 2 times 12 times 24 times the cosine of 30 degrees. So if I round that to the nearest tenth, I get 14.9. So side length A is 14.9 units. Okay. Now at this point, because you do now have a pair, right? Again, I'll try to make that clear, right? I know angle A. Oh, geez, Douglas. Wow, it's going really well so far. Sorry, meant to highlight that. I know angle A and I know side length A. So now I can use the law of sines. If you'd like to continue with the law of cosines, you will need to use one of these three at the bottom, which is really just those three at the top rearranged to solve for the cosines. All right, we will be using that one of those on the next example. All right, but really at this point, I think the law of sines is a little easier to do and a little simpler to remember. So I'm actually going to use the law of sines. So now I know sine of angle A over A equals, and I'm going to go ahead and solve for my next angle. And I always choose the one that's going to be the smaller of the two angles. If you analyze side length B and side length C, you can see side length B is actually half of side length C. It's smaller. So I'm going to solve for angle B. The reason I do that is I don't want to mess up my angles. because remember, sine is positive in the first and second quadrant, so it can't differentiate between those two. So always leave, this is kind of the rule of thumb, leave the longest or the biggest angle or the longest side length to the end as much as you can. All right, so sine of 30 degrees over 14.9 equals the sine of, I don't know, over 12. So cross multiply, get 14.9 times the sine of angle B equals 12 times the sine of 30 degrees. Now, I do want to solve for B. All right, so what I'm going to do is I'm going to kind of do this in these two steps in one and see if you're okay with this. I'm going to first move this 14.9 over to be in the bottom, but then to get angle B by itself, I'm going to need to do sine to the negative first power of that fraction, all right, which we practiced last lesson with the law of sines. All right, so this will give me angle B. All right, again, when you're doing this, I'm not that concerned about the rounding part, but technically if you really wanted to, again, wait till the end to round, you should really use this whole thing. But if you use 14.9, I'm really not concerned about it. So I'm going to type in sine to the negative first power, and my fraction is going to be 12 times the sine of 30 degrees over, and again, you have options here. Type in 14.9, or you could type in this whole thing or copy and paste that whole thing. And you get 23.7, it looks like 23.7 degrees. Again, if you get 23.8 or 23.6, I'm not going to be worried about that on the test. All right, now we're almost done. All right, that's angle B, 23.7 degrees. So my last part is to get the angle C, which since now I know 2 out of 3 angles, I can just subtract the sum of the other two from 180. All right, so that will give me angle C. So let's do 180 minus the sum of the other two, which was 30 plus 23.7. So 126.3 approximately. All right, so that is my angle C. Oh, my bad. Change the numbers there. 126.3. All right, so that's it for the first one. So again, you'll notice I used the law of cosines first to find my missing side length. Then that allowed me to have a pair, right, an angle and the corresponding side length, which allowed me to then use the law of sines. If you want to keep going to the law of cosines, you can absolutely do that. You just have to use one of these bottom 3 iterations where you're solving for the angle. All right, let's do one more. All right, so here is our triangle ABC, just like we had before. Side length A is 5, side length B is 7, and side length C is 10. And this is one where I'm hoping, as you get used to this, is you'll notice right away, we don't have a single angle. So it's pretty clear that we can't use the law of sines, because the law of sines, you have to have at least one angle and that corresponding side to that angle. But if you don't have any angles, you got to go straight to the law of cosines. And because I know all the side lengths, I'm not going to be using any of these 3, right? That's how I use the law of cosines to find a side length. So I'll be using one of these 3 down here to find a missing angle. So I'm not going to use, I always just start with the one that I know will be the smallest angle. And you'll see that side length A is the smallest. So I'm going to find the cosine of angle A, and again, use your formula if you need to. Cosine of angle A is equal to b squared plus c squared minus a squared. So b squared plus c squared minus a squared all over, and in the denominator we have 2 times b and c. Okay, so plug in what you know. We know b is 7. C squared is going to be 10 squared minus a squared, which is 5 squared, all over 2 times 7 times 10. Now again, when I go to the calculator, right, I'm going to be solving for angle A, which means I need to do cosine to the negative first power, right, the inverse operation of this fraction, because this fraction is the ratio, and I'm trying to find the angle that when I take the cosine of it, I get this ratio. All right, so let's see what the calculator is going to give us for the cosine, or excuse me, for my angle A. All right, so let's delete this. I have cosine to the negative first power of my fraction. see if I can remember it. I believe it was 7 squared plus 10 squared minus 5 squared over 2 times 7 times 10. Confirm I have that. 7 squared, 5 squared. Okay, looks good. So rounded is 27.7 degrees. So angle A is 27.7 degrees. So angle A is 27.7 degrees. Now, at this point, you now have an angle, right, like we had before. We now have enough information to do the law of sines because I have a corresponding angle and its corresponding side. So I'm going to go ahead and use the sine of A over A, right? And again, what I mentioned in the first example is I wait until the last possible moment to find the largest angle or the largest side. So I'm going to go to the next one, B, because 7 is less than 10. So the sine of B over B to find angle B. So the sine of 27.7 degrees over 5 equals the sine of the angle I'm solving for over 7. Cross multiply. So 5 times the sine of B equals 7 times the sine of 27.7 degrees. Now again, I'm going to do what I did on the last one and do this kind of in one step here, even though it's really two. I move the 5 over with division, right? So I get this fraction. And then because I want to solve for an angle, I've got to do sine to the negative first power of that ratio, right? So it's telling the computer, here's my ratio. Tell me the angle that when I take the sine of it, I get that ratio. All right, so sine the negative first power of, and in that fraction, I'm going to have 7 times the angle I found before, which is 27.7. Again, if you want to not round, just copy and paste it. Not really worried about the rounding part here. Over 5. So that's 40.6 approximately degrees, 40.6 degrees. And so my last one, if this is 40.6 degrees, is to find angle C. I do the sum of the other two subtracted from 180. And that will give me all three angles in this triangle. All right, so 180 minus the sum of the other two, 27.7, plus 40.6. Oop, got my stuff all. There we go, that's more like it. 111.7 degrees. Now, before I wrap this up, I just want to make sure you guys are good on both of these, right? On the first one, you had to use the law of cosines to find the missing side length A. From there, you had choices. If you wanted to use the law of cosines to find an angle, you would have to use one of these bottom three iterations of it. But I decided to use the law of sines now that I had enough information. Same thing on the second one. I had to use the law of cosines to find an angle first. Then you've got options. You can continue to use the law of cosines to find the next angle B if you wanted to. I went ahead and switched to the law of sines. You're going to see that I always do that if I can. I try to use the law of cosines as little as possible because it's a lot more to memorize. It's a lot clunkier, a lot more stuff, a lot more chances to mess up. I think the law of sines is a little bit simpler as you're dealing with less stuff and just proportions. All right, so that's it for the law of cosines. Good luck.